So for the first problem, we have a multivariable function here. It's a two-variable function is how we describe it, with a third quantity being the output quantity of temperature. And so what we have is the temperature on a metal plate. So on a two-dimensional metal plate, we're going to measure the third dimension. Dimension in this case is just the temperature at that location. So imagine maybe a metal plate with some source of heat underneath it, and the temperature of that metal plate changes maybe as we get further and further away from the source of the heat. And so location X and Y, temperature T, X and Y are measured in centimeters, the temperature is measured in Celsius. And look, they've given us a contour plot as well as a surface plot. Thank you very much. We'll use them as needed. So our first job is to calculate the gradient vector. So let me remind you that the gradient vector is a vector that's made up of the two partial derivatives. That is, if we take the partial derivative with respect to x in the I direction, plus the partial derivative with respect to y in the j direction. I'm going to use the ij notation. You don't have to. You can use your other different vector notations. It's totally up to you, but I'm doing it this way for now. So let's come over here and compute those two partial derivatives. Let's start with the partial derivative with respect to x. So if we're taking the derivative with respect to x, only x is changing, y is being held constant, and so the partial derivative is really just going to be the derivative of this term. So by the power rule, the 2 comes out front, decrease it by 1, so 2/4, a half, x to the first. So negative a half, x to the first, negative a half x. And then kind of likewise, except reverse, we're now going to hold x constant and just allow y to change. So 2 out front, decrease by 1, also negative a half, but y is the partial derivative with respect to y. Now notice we're supposed to compute this gradient vector at a bunch of different places, different points on this metal plate. And so let's first get it done generically here. So the partial derivative with respect to x, negative a half x, I, plus negative a half y, j. All right, so the gradient vector at these different points a comma b. So in the first case, a is -1, b is 0. So at the point -1, 0, if x is -1, that would be positive 1/2 I. If y is 0, that is just 0. So this would be the vector 1/2 I. So let's just emphasize here that the gradient is indeed a vector. And so the vector in this case at -1, 0 is 1/2 I. What about -2, 0? Negative a half times -2 is 1 I. If y is 0, that term goes to 0. So this would just be the vector I. 1, 1. Negative a half times 1, negative a half times 1. So this would be the vector negative a half I minus a half j. How about 0 square root of 2? Well, if x is 0, that term is out. If y is the square root of 2, we would just get negative 1/2 times the square root of 2. We could say negative the square root of 2 over 2j. And then 0 negative square root of 2. So 0 is going to take that out. Y is negative the square root of 2. So now we're going to get positive square root of 2 over 2j. Now for each of these, we're to sketch them on the diagram. Let's start. So we're at the point -1, 0, and the vector is 1/2 I. So we're at the point -1, 0, that's right here, and the vector is -1/2 I. So we want to go a half a unit in just the I direction, so it would be this vector right here. -2, 0, that would be here. The vector is I. I don't know why I did that. Let me try that again. It's a half I. I don't know what I was thinking. A half is positive, so it would be this way. And at -2, 0, it's 1 I. So it would be 1 full unit in this direction. It would be that vector there. All right, at 1, 1, that's at point P, we'd have negative a half I minus a half j. There's my negative. So it'd be negative a half I minus a half j. So negative a half, it would be this vector here. And at 0 square root of 2, so 0 square root of 2, that must be this one here, since square root of 2 is about 1.4, so we're just shy of 1.5. And the vector is negative square root of 2 over 2j. So a negative square root of 2 over 2j would put us this way. Let's see, I probably made that too long because it's half of the square root of 2. So it's like about that long. And then 0 negative the square root of 2, that would be down here, and it's positive. So it would be pointing this way. Now what all of this is supposed to illuminate is something special about the gradient vector. Notice at the point, the gradient is perpendicular to the level curve at that point. So at this point, the level curve is flat, I mean instantaneously speaking. So perpendicular, 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 and perpendicular. Yeah, the gradient vector is perpendicular to the level curve at that point that we're on.